slideshow set up, and we may even turn on the projector today. Who knows? All right. We'll go from the current slide. Okay. First, I want to make sure if there are any questions, we get those answered first. Oh, yeah. I meant to ask that. Anyone need the take-home test? Okay. Too bad, too late. No, I'm just kidding. Okay. All right. 1, 2. Oh, sorry. 3. And it must be raining outside.
A little bit.
A little bit.
Almost failed.
Is that 1 or 2? You only get 1. Okay. All right. All right. What's that? It's a week from today. Yeah. If you need more time, I usually give it, but and if you finish it sooner, you can turn it in sooner. Okay. Any other questions before we get started? All right. We were on example 5, and we had done the A part. And this was the A part, and we finished that. We're getting ready to do B. Any questions before we move to B? All right. Now, oops. Actually, I'm going to do it right here. Here's example 5B. The tangent of negative 210 degrees. Now, there's several ways you can approach this problem, and as long as you do your way right, it should give you a right answer. How would you approach that problem? Tangent of negative 210 degrees. It's on the top of page 294, chapter 4, section 4.4. What would be your approach? We did A last time. B, how would you do B? Come on, give me a hint. Don't leave me hanging. Don't wait for EJ to come in. Okay. All right, let's hear. How would you approach a problem like that? You're trying to determine the tangent of negative 210 degrees. Surely you'd have a first step. What would be your first thing you would think of to do? Try to determine that. Draw a picture. Yes, please. Thank you. All right. Draw. Whoa, let me get my pen activated correctly. All right. Okay, let's draw that good old unit circle. I don't draw circles very well. Okay. Then what would you do? I drew the circle. Where would you start? Where does everything start from? Say again? Always starts from the positive horizontal axis. And then where do you go from there? Okay, I saw the air drawing there. I think that was going downward. Okay, because it's a negative. You go downward. And how far would you be if you got to here? In degrees. How many? Negative 90 degrees, so keep on trucking. When you get up to here, how far are you? Negative 180 degrees. You have a little bit further to go. How much further? Say again? From 180 to 210. Oh, another 30 degrees. So that's not too far. That would be somewhere about like there. So this would be negative 210 degrees. That's how I would start the problem too, I think. You know, find out where you are, Waldo. Okay? Now, how would you figure out what the tangent is there? There's basically 2 steps to do here. You've already really done one of those steps. What are the 2 things you need to determine to get the tangent of negative 210 degrees? Say again? Two things you need to know. First, the answer is going to have a SIGN sign affixed to it, right? Now that's not first, you can do that last, I don't care. The other thing is going to have a value associated with it. Now what's the value related to? And in her getting me there, Amber basically already told me what it was. I don't know if she realized that she did. Uh-huh. Okay. To get the value, what surrogate angle would you use? That's not the name we use, but I'm just trying not to give it away. The what?
The angle of the negative 210 degrees.
Okay.
The x-axis.
Okay, the angle that terminating side makes with the horizontal axis. You're absolutely right. And what angle is that? 30 degrees. You told me that. So this is, and what do we call that? The reference angle. So your what they usually call theta prime is 30 degrees. Always a positive acute angle. The acute angle made by the terminal side and the horizontal axis. 30 degrees. Okay? Now, can you tell me the tangent of 30 degrees? That'll be the value I was talking about. The tangent of 30 degrees. And here's, I think, the jargon under all that. Okay? Good class so far. We're only missing 1, 2, 3 people. Hopefully they'll come in. Anyone know what the tangent of 30 degrees is? A little louder. Tangent of 30 degrees.
It's 0.58.
Okay. That is an approximate value to it. Can anyone tell me the exact value? In other words, it's going to have a radical in it. It's what? Root 3 over 3, is that what you said? I think you hit it, okay? Now, here's how I do 30, okay? We're looking for the tangent of 30 degrees. That's your reference angle. That would be the sine of 30 degrees, which I remember fairly easily, over the cosine of 30 degrees, which I can get pretty easily too. Sine of 30 degrees is 1/2, and the cosine of 30 degrees is square root of 3 over 2. So when you do that, sure enough, you get 1 over root 3, which is the same as root 3 over 3, which I think, when you go back and do your calculations, that'll be approximately 0.58. Now, that gives you the value. What gives you the SIGN sign? Where are you, Waldo? Which quadrant? And what do we know about second quadrant? All students take calculus, or chemistry, or whatever, all state technical calculus. However you want to call it, all your trig functions, all 6 of them, are positive here. Only the sine and its reciprocal are positive here, which means that tangent would be negative there. So that gives you the sign. So that would be negative root 3 over 3. Okay? Which I think would be negative 0.58 or somewhere close to that. All right. Feel like a dentist, okay, but otherwise, that makes sense? Okay? Can we go to the next one? Okay, do you want to see how they did that one? Well, I'll leave it up there a bit longer. First thing I like to do is find out where you are. Now, I think what the book does, they do the coterminal angle. You can do that if you want to, but God, my goodness, it's not hard to go around just in a clockwise direction and figure out where you are. Y'all did it perfectly. You got to 30 degrees above the horizontal axis in the second quadrant. So You know the reference angle, 30 degrees. You know what the tangent of that reference angle is, square root of 3 over 3, and you know that tangent is negative in the second quadrant. There's your answer, okay? Now you want to see them work it, or you want to go on and do cosecant while we're here? Earth to class, come in please. Yes, what? I'm sorry. Okay, let's do it. Okay? Can I erase what we've done so far to keep it from being too muddled, befuddled, or whatever? Okay. I'll kind of keep my my circle. Okay. I'll try to draw a vertical line through it. Now, cosecant of 11 pi fourths, what's the first thing we got to do? Figure, where in the world are you when you're at 11 pi fourths? How would you figure that? Give me a hint. How would you start? First, what's the sign of 11 pi fourths? Thought that would be an easy question. Positive, okay? That means which way you're walking. Or circling. Counterclockwise, okay? So we're going up here, okay? Now, does anyone know what pi fourths is? Yeah, that's your 45. That's your diagonal right there. So there's 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths. You can do it this way if you want to. 5 pi fourths, 6 pi fourths, 7 pi fourths, 8 pi fourths. I knew that because one time around would be 8 fourths pi, right? 8 fourths is 2 pi, okay? So the one more would be 9 fourths pi, 10 fourths pi, 11 fourths pi. We'd be right here. So what we've done is done that. There is 11 fourths pi. Okay? All the way around to there. Okay? That locates where you are. Now, you didn't need to do it that way. You could do it any way you wanted to. You could have said, I know that, let's just subtract 2 pi from this because that's too big. Well, 2 pi is 8 fourths pi. Subtract that, you get 3 fourths pi. Where are you with 3 fourths pi? 1 fourth pi, 2 fourths pi, 3 fourths pi. Yeah, you wind up there however you do it, okay? So what does that tell you? Say again? Tells you what quadrant you're in. Second quadrant. Okay. What else does it tell you? What is positive? The cosecant? The cosecant is positive. Why? Yes, because it's reciprocal of sine, and sine is positive in the second quadrant. Absolutely correct. So we know our answer is going to be positive. The power of positive thinking. Okay, we got it. Next. Can you give me a value for it? What would you need to detect or identify to get the value for that angle? I don't like 11 pi fourths. It's just way too big, bulky, ugly. What angle would I rather work with? Boy, how soon we forget. It was good 5 minutes ago. The reference angle. And what is the reference angle for 11 pi fourths? Pi fourths, of course. It's that little angle there between the terminal side and the horizontal axis, and that's pi fourths. So your reference angle, theta prime here, is pi fourths. Now, I don't really like messing with cosecants very much because they're not one of my favorite trig functions. But they're related by what? Okay, and how are they related? Sure you do. The what? Yes, not opposite over adjacent. Is that what you said? Not opposite over anything, really. Opposite is in there, but not over. It's one of your trig identities, see? Reciprocal identity. So it's 1 over sine. So this is going to be 1 over the sine of your reference angle, which is pi fourths. And the reason we're using positive is because sine and cosecant are positive in the second quadrant. And what is the sine of pi fourths? Oh boy, you need to get to know these things. They are friends of yours, real good friends. You don't forget their names, do you? Okay. Sine of pi fourths is square root of 2 over 2. And another name for that would be 1 over root 2, right? So if sine is 1 over root 2 and cosecant is its reciprocal, then cosecant would be sine is 1 over root 2. That would just be root 2. Reciprocal of 1 over root 2 would be root 2. Right? Now, does that even make sense? Yes, because cosecants are always greater than or equal to 1 or less than or equal to minus 1. Square root of 2 is greater than 1. Right? 1.414, something like that. So that is your cosecant of that. Make sense? Find out where you are. Go around the circle, whatever it takes. Find out where you are, Waldo. Okay? Depending on where you are, that gives you the SIGN sign. This happened to be positive. Then it also tells you or indicates to you what the reference angle is. Find where that terminal side is, go to the closest horizontal axis, see what angle that is. This happened to be pi fourths. We know the sine of pi fourths, sort of, root 2 over 2, which is the same as 1 over root 2. So cosecant is reciprocal of that. That would just simply be root 2. Make sense? Get to know these values, these that we use all the time. Okay. So let's see how they did it. There was the A part. We got that. Here was the B part. Now the first thing they do is find the coterminal angle. Yeah, you can do that if you want to. It was perfectly legal move. Add 360 to it, you get 150. Then find out where you are. Going positive 150 is the same as going negative 210. Well, that's 30 degrees short of getting to 180, right? So again, you get which quadrant you're in, second quadrant. Again, you get that reference angle, 30 degrees. So it follows that negative 210 is coterminal with the second quadrant angle, 150. Okay, fine. You could have gotten the same thing by going around clockwise, but who cares? Either way, fine. So reference angle will be 30 degrees because once you found out you were here, and here they just show it. There's negative 210, you're 30 degrees past 180. That's your reference angle, 30 degrees past it. That's your 30 degrees. Always a positive acute angle. So what you need now is to know the tangent of 30. Well, two things. What quadrant are you in? That gives you second quadrant. What sign the tangent is there, SIGN sign, negative there, and then what the value is, tangent of 30 is. So this will be the minus the tangent, minus because you're in second quadrant. Tangent of 30 is root 3 over 3, so minus root 3 over 3. You banged it really good. Got it. Right? See how you got it? Any questions on it? Do I need to go back a slide? Okay? So that was the B part. Okay. So find out where you are. That gives you the quadrant. That should give you the SIGN sign. And find that reference angle. That gives you the value. And put the sign with the value. You got the answer. Make sense? Any questions? Okay, let's do the C part. So here we have 11/4 pi, which is an awfully big number. So we're going to subtract 2 pi from it, which I don't really like to do that way. I would subtract 8/4 pi because 8/4 is 2. That would be 2 pi. And 8/4 is easy to subtract from 11/4 than 2 pi is. So 8/4 from 11/4 would be 3/4 left over. So where are you at 3/4 pi? You're over in the second quadrant angle, 3/4 pi. Okay? Now you can do it by going around the circle, or you can do it by subtracting. However you do it, get to the second quadrant. Okay? Now, you know you're in the second quadrant. You also need to know two things now. What the SIGN, sine relationship, is for your angle, for your trig function, is in the second quadrant, and also what the reference angle is. And if you're 3/4 pi over there, you got 1/4 left to get to your horizontal. So that gives you pi fourths. Okay? So the reference angle is pi fourths, and this shows exactly what we did. You start here, since it's going counterclockwise because it's positive, and you can count off your quarters if you wanted to, or count off 2 pi, 2.5 pi, 2 3/4 pi. That's exactly what this is. 2 3/4 pi is right there, and then your 1/4 pi is short. So your reference angle is pi over 4, and you're dealing with cosecant. Cosecant is the same sign as sine, SIGN is sine, because it's a reciprocal of it. So that would be 1 over the sine, positive in the second quadrant. So cosecant will be positive. So it's 1 over sine of pi fourths, and sine of pi fourths is 1 over root 2, so 1 over root 2 is root 2. A good way to check is look at that and see if the value is right. Yes, cosecant has to be greater than 1, could be equal 1, or less than -1, because it's positive greater than 1. Square root of 2 certainly is. That gives me a warm and fuzzy that I probably do have it right. Make sense? Are you thinking trig yet? They say when you're learning foreign language, you really get good when you stop translating everything and start thinking in that language. Are you thinking trig yet? Get used to it. Practice lots of problems, and after a while, you'll be thinking trig, and then you'll know you're there. Okay, right? Okay. Everybody got it? Any questions? Okay, they say that's the last slide. It's not the last problem, though, so let's go back. And maybe right here, let's do example 6. And by the way, there was a checkpoint, and since I had to pull so many teeth to get those 3 done there, I would suggest doing the checkpoint so you can still have some teeth in your mouth, okay? I don't want that. Okay. So let's do example 6. Here's how example 6 goes. Let theta be an angle in quadrant 2. Okay, that's all they tell you about theta so far. Such that, now they're going to give you something else, sine of theta is equal to 1/3. Now, time out. Do those two statements, are they agreeable with each other? Are they congruent? Do they make sense? If theta is in quadrant 2, can the sine of theta be positive? What you think? Yes, sine is positive in the second quadrant. All students take calculus. Sine is positive there. So that does make sense. And it makes sense that Jasmine's here. Okay. All right. So now we're just missing 2. No, 1. James. If we had James here, we'd have perfect attendance. Because the other 2 people, I guess, are not coming back. They're no longer on the roll, so I've scratched them off. So we're 10 on the nose with this. Say again?
She said sine is positive in the second quadrant.
Yeah, sine is positive in the second quadrant, remember? Do your quadrants. All students take calculus. Student stands for sine and cosine, because that's reciprocal of sine. So it's positive there. Okay? So we're told that theta was in quadrant 2, and we're told that the sine is positive there. Yes, those two go together well. Now, what doesn't go together too well is that 1/3 is not the sine of any angle that we have been studying. Okay? There is an angle with a sine of 1/3, but it's not one of our favorites. We like our favorites, but y'all don't know them anyway, so this is a stranger. Okay? We can deal with it. Okay? Now, let's see what it's asking. Find cosine and tangent by the trigonometric identities. Okay? Now, I'm going to do it two ways. You can either do it by the trig identities, or you can do it another way. Frankly, as Amber might guess, I like pictures. Okay? Right? So I'm going to draw me a little picture of quadrant 2. Okay? I know where that is. And we know that sine is, by the way, tell me what sine is. Say again? Okay, it's positive. I got that. But what is the definition for sine? We have several of them. But let's do an x, y, and r. Say again? Opposite over hypotenuse. The opposite side is the, so let's start with this. Hypotenuse is 3, right? We agreed to that. So there's 3 there, there's 3 there, there's 3 there, there's 3 there, okay? It's not a unit circle, it's a 3 circle, okay? I don't know what you call that. So anyway, there's my circle, sort of. Now, I got the 3, that's the hypotenuse. That's your, also the radius, r, right? Same thing. The 1, the opposite would be, okay, I'm going to sort of draw an angle here. The opposite would be this value here. What is that value? This here. Yeah, it's 1, yeah, we got that. But what does that correspond to? Your y. The opposite is the same as y. So you said it's opposite over hypotenuse, yeah, opposite adjacent hypotenuse, or you could have also used, give me another color. Say again? Pink? Well, I'll give you a red, okay? All right. Another way to express this is x, y, and r. And think of it that way too. Sine is y over r. Okay? So, we've got that. Now, what they say to do is use the trig identities. Okay? And we'll do that. It said find cosine. How is sine and cosine related to each other? Second cousins twice removed. No. How are they related? What's the trig identity that relates sine and cosine? Oh, I can't think of a single one. Can you? Know these identities. They are important. They're your friends. They help you out in all sorts of problems, like this one. How are sine and cosine related? One we use a lot. Folks, second, sine and cosine aren't reciprocals of each other. Sine and cosecant is. Cosine and secant are, but sine and cosine are not reciprocals of each other. I'll give you a hint. In my little drawing here, sine is related to the opposite side. Cosine is related to adjacent side. How are they related to each other? Okay, that's true. Absolutely true, except we don't have any tangents in this problem. We do in the B part, but not in the C part, A part. Okay? You've already X'd off your reciprocal identities, and now your quotient or ratio identities. There's one other class of identities you're avoiding like the plague. The Pythagorean identities. Are they sine and cosine related there at all? Please say yes. All right, how? How are sine and cosine related in your Pythagorean identities?
Sine squared.
Oh my goodness, yes. We knew that, didn't we? Sine squared theta plus say it again.
Cosine squared.
Second is equal to 1. You got it. And we know what sine is, what? Don't we?
1/3.
1/3. But we're going to square that, so that'll be squared. Plus cosine squared, we don't know what that is, so we'll just leave it cosine squared, is equal to 1. And what is 1/3 squared? 1/9 plus cosine squared theta is equal to, I'm not going to write it as 1, I'm going to write it as so many ninths. How many ninths is 1? Oh, tough question. 9/9, of course it is. 1 is 9/9, right? And that helps me do my subtraction, right? Because I want to subtract 1/9 from both sides. And what does that give me? Cosine squared theta, this adds to 0, is equal to, say again? 8/9. Very good. Now, I don't really care what cosine squared is. I want to know what cosine is. And what is it? How do you get it from cosine squared to cosine? Take a square root. So that would be cosine theta is equal to, a little louder, plus or minus, don't forget that, plus or minus the square root of 8, and what's the square root of 9? 3. Square root of 8 over 3. Now you're doing with the cosine. What is the cosine? Where are we, Waldo? Quadrant 2, right? And we're at what is cosine in the quadrant, in the second quadrant? Is what? Negative. So we forget about the plus sign. We've got the negative sign, and guess what? We got the problem not. Okay? Because it's negative square root of 8 over 2. Now, you might like writing square root of 8 because that has buried in it a perfect square. So you might write that as minus 2 root 2 over 3. You don't have to, but that is another answer. Because square root of 8 is square root of 4 times 2. Square root of 4 is 2. Square root of 2 is square root of 2. So, yeah. All right, so now we got cosine. That was the A part of the problem. Now, I love the Pythagorean identities. They're so nice, you know, and very helpful, and we love memorizing them and knowing them really well, don't we? Okay? But, guess what? Guess what, team? Look over here at our illustration, x, y, and r. We know the y is 1 and the r is 3. You told me that to begin with, right? Because sine of theta is 1/3. And you're in the second quadrant. You can calculate x pretty easily, can't you? By what? Hint. That's a right angle right there. Pythagorean theorem, of course. So what would x be? You'd have x squared plus y squared equal r squared, right? That's Pythagorean theorem, right? That's why we call it the Pythagorean identity, because it looks just like that, right? Okay, your x was, we don't know, so x squared plus 1 squared is 1 is equal to 3 squared, which is 9, and that would mean x squared is equal to 8, and x is equal to the square root of 8, which would be plus or minus square root of 8. But because we see the x is over here in negative territory, right, that would be minus 2 root 2. Okay, and once you know that, you can just write down the cosine of this angle right here is x over h, adjacent over hypotenuse. X over r, adjacent over hypotenuse is the same thing. Square root minus square root of 2 over minus 2 root 2 over 3. To me, that's easier than the Pythagorean identity. Okay, but they're the same thing. They give you the same answer. So here we've gotten our cosine. The B part asks for what in the world is a tangent of theta? How can you do that? Tangent theta is equal to what? And I think Amber already told me what it was. It was a long time ago, at least 5 or 10 minutes. It's sine over cosine. Sine theta over cosine theta. And guess what? Okay, we knew sine already was 1/3, and we just discovered that cosine was negative 2 root 2 over 3. The 3's go out. Your answer is going to be minus. Sure enough, tangent is negative in the second quadrant, so that makes sense. Okay, negative 1 over 2 root 3. Okay? Now, you could have looked at our little figure here and said it's y over x would be 1 over negative.
I'll just say 2 root 3.
So I guess?
I'll just say 2 root
2 root 2. I'm sorry, I can't read my writing. 2 root 2. Okay. I couldn't read that writing there, and that's a 2, not a 3. Okay. All right. So you could have gotten it two ways. You could have gotten it sine over cosine, or you could have looked here at our drawing 1 over, I'll just write it in here, negative 2 root 2. Okay? So either way you do it, you get that. Now, if you don't like radicals in your denominator, what could you do? Multiply numerator and denominator by root 2. And that would give you root 2 over 2 times, root 2 times root 2 is 2. That would be root 2 over 4. So if you don't like the radical denominator, you could express it. Oh! Minus. Tangent is negative in the second quadrant. Okay. Now, how did the book do? They got cosine being negative 2 root 2 over 3. Good for them. That's what we got. And then they got the tangent to be negative root 2 over 4. Excellent. There is a checkpoint here. And since it seemed like maybe you're a little rusty about that one, maybe it might not be a bad idea to do the checkpoint. As soon as you can, as soon as class is over, you're free from here. Okay? Now, any questions on that? All right, let me clear all the writing if you got it. Yes? Where's what? Up here somewhere?
Uh-huh.
And what about it?
We did it from the top.
What's that again? Read it. Sine over cosine. Sine we had from the given problem, 1/3, over cosine, which we had was negative 2 root 2 over 3. So that's what's there, negative 2 root 2 over 3. And then what I did was cancel out the 3's and multiply both sides by 3 over 3. Numerator and denominator by 3 over 3, which got rid of those. That gave you a negative 1 over 2 root 2. And then to get rid of the radical in the denominator, multiply the numerator and denominator by root 2. That would make root 2 over 4. Negative. Because the minus sign. Or we could have gone straight to here and done 1 over negative 2 Either way works. Frankly, I just kind of like to draw my little pictures, ugly though they are, and set them up, figure out what the coordinates are, and then you can do any of your trig functions from those. Okay. All works. Okay. Someone turned off the lights, didn't they? Okay. Wow. Okay. Any questions on that? All right. Someone's ready to go to bed too, I think. Okay. Now, all right. Let me, if you're okay, I'll clear this. Are you? Okay. So let's erase all the ink. Now let's do example 7. Use a calculator to evaluate each trig function. The first is cotangent of 410 degrees. Okay? So what we do, make sure we are in what mode? Degree mode, exactly, okay? And then you find your cotangent key, right? No. Most calculators don't have cotangent keys. Now, actually, somebody came up with a real fancy calculator that did have them. If you have a cotangent key, use it, but most of them don't have a cotangent key. So are we sunk? We're dead in the water? Can't do anything with this? Say again? It's a reciprocal. Is that what you said? No, I couldn't hear you. What would you put down? And there's several ways you can approach it. Is 1 over the tangent of 410 degrees. And guess what? Your calculator will accept that even though you don't have it in reference angle, you haven't figured out what quadrant, your calculator will take care of all that. Now, the other way you could have done that is done, here's the other option, tangent of 410 degrees, and then do the 1 over x key, or reciprocal key. Either way would work, but be sure you're in degree mode, and then either take 1 divided by tangent of 410, or tangent 410, and hit the reciprocal key, and see what you get. Okay? They suggest doing the reciprocal key first. And notice they do put you get in degree mode, you open a parentheses, you press the tan key, your calculator does have a tan key, it doesn't have a cotangent. Then that opens a parentheses for you most of the time, do your 410, because you're already in degree mode, close the parentheses for the tangent, close the parentheses in front of the tangent, then do your reciprocal key, which they list as the x to the minus 1 key. Some old calculators have 1 over x, and then press enter. What do you get as an answer? Has anyone got your calculator and doing it? What do you get as an answer? 0.839, blah, 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 blah. Yes, very good. Now, I'm always a cynic. I don't trust those little black boxes sometimes. I think I may have hit a key wrong. I want to make sure that makes sense to me. Where is 410 degrees anyway? Second? Yes, because you go all the way around, that's 360 degrees, and then you've got how many left? 360 from 410? 50 degrees you got, yeah. First quadrant. So I feel good about that giving you a positive answer because all your trig functions are positive in the first quadrant. That doesn't give you exactly, but then you can do tan of 50 and see if you get the same answer. And hopefully you do. Okay? So your calculator took care of all that for you. Okay. The next one here is sine of -7. What are you going to do to get that? Does that even make sense? You tell me, what mode do you get into? Radian mode. If you don't see a degree symbol, you got to be in radian mode. So you get in radian mode first, and then it's a piece of cake. Just make sure you're in radian mode, do sine -7. Okay? Now, some of you may have older scientific calculators. You might need to do the -7 first. But actually, on the old calculators, you press the 7 first, then the change sign key, which sometimes is CHS, sometimes a plus minus, and then you hit the sign key. But most of the newer calculators, especially graphing, you do the sign key, it opens a parentheses, you type in the negative that's in parentheses, not the subtraction key, but the negation key, one in parentheses, negative sign, then 7, close your parentheses, hit equal, you got the answer. And what is that answer? Has anyone done it? Anyone going to do it? Hint, hint, do it. Okay, okay, someone's doing it, good. I'm almost beginning to think I could work it from scratch first. No, I can't. Okay. You get an answer? Anyone get an answer? Okay, a little louder. Negative 0.656, blah, 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 blah. Very good. 656.9, blah, 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 blah. Okay. 98, blah, 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 blah. 9866, blah, 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 blah. Okay. Yes, absolutely. But being the non-trusting cynic that I am, I want to make sure that's right. So sine of -7. If I start here, my positive here, which direction am I going to turn? Clockwise, right? Because this is -7. Okay, how far do I go? 7. I know over here is pi, which is 3.14. Back around to here would be 2 pi, which is 6.28, blah, 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 blah. And 7 is just a little bit beyond that, right? So what quadrant am I in? Fourth quadrant. And sine is what's sine in the fourth quadrant? The SIGN? So it's negative in the fourth quadrant. So at least my SIGN sign is right. And then, you know, you can figure what portion of that it is. I feel good about it. And it is correct. We look at it too. Okay, how about the secant of pi ninths? How in the world are you going to do that? Any hints? If you had that on the test, it said, use a calculator, find the secant of pi ninths, what would you do? Skip it and go to the next problem and get a 0 on that. Shame on you. How do you do that? First, what mode are you in? Always the first thing to check. What mode are you in? What mode are you in? I keep hanging a participle there. No, preposition. Say again. Yeah, you're in radian mode. You don't see that degree symbol. So you're in radian mode. And now you find your secant key, right? How many of you have a calculator with a secant key? None. Okay. So what do you do? Use what?
Flip it.
Okay, flip it. I got it. And do what? 1 over the what? Secant is 1 over what? Get to know them, okay? These are your identities. Important. Secant is 1 over what? Okay. Remember when we first started off and we were trying to calculate the things, I'd always start with sine of theta, then I'd write cosine of theta, and then I'd write tangent of theta, and then I'd go over to the right and write cotangent theta, secant theta, and cosecant theta. I did it that way because these are reciprocals of each other. Cosecant and cosine and sine and secant are reciprocals of each other. So you do 1 over cosine, not cosecant, cosine. Cosine, 1 over cosine of pi ninths. Okay. Now, you can either do it that way or you can do, and this is what the book suggests, open parentheses, cosine of pi divided by 9, close, close, and then do the -1 key, and then press enter. Okay. The reciprocal key. Okay. Either way you want to do it, whichever you understand best and makes most sense to you. Okay. And by the way, cosine of pi ninths is pretty close to cosine of 1/3. Not exactly, but pretty close to it. And that's a fairly small radian number, because pi ninths is a pretty small angle. So this is going to be something fairly close to 1. Okay, positive or negative? Yes, 0.939, blah, blah, blah. Okay? No, wait, no, well, couldn't be. Not if you did the reciprocal of cosine. Because remember, secants are always greater than 1 or less than -1. That doesn't compute. That's, say again? That, it was the cosine, I think, is what it was. Do the reciprocal of that and you get, what's that? Okay. All right. Are you doing the reciprocal key or are you doing 1 over key? 1 over, which way are you doing? Divided by. 1 divided by cosine of open parentheses, pi over 9, close parentheses, equal. That's got to give you a positive number. And it's got to be a number greater than 1. Not 0.9. I think what you got was the cosine. I think that's cosine of pi ninths. So this is, I'm guessing 1 over that. I don't know for sure, I'm just guessing. Anyone got an answer? Is anyone besides she trying to get an answer? Second, it's got to be greater than 1. What you get? Yeah, blah, blah, blah. Yes, you got it. That's it. Okay? And the reason, you know secant cannot be a number between -1 and 1. It's got to be outside of those. This is a very small angle. Cosine of small angles are close to 1, because cosine of 0 is 1. Anyway, it's in the first quadrant, so you know it's positive. So this is going to be 1 over a number close to 1. That's going to be a number close to 1 too, but it's going to be greater than 1. So yeah, that's your answer. Thought these were easy. There is a checkpoint there. Please do the checkpoint. And if you can't get them, go to LarsonPrecalculus.com. You'll see audio, video solutions for those. Let's do our vocabulary. Boy, do we need to do the vocabulary. Exercises 1 through 6. Let theta be an angle in standard position with xy being the coordinates, the point on the terminal side of that theta, and that x and y can be anywhere around the circle. Positive or minus x, positive or minus y, either one. And r, though, is the square root of x squared plus y squared, and that r is never 0. The only way it could be 0 is x was 0 and y was 0, and then you don't have a point at all, or an angle at all. But r is always, it's never 0, but it's always positive, can never be negative. X and y can be negative or positive, but r can never be. So, I want you to give me what that relationship is in x, y, or r. Okay? Let theta be an angle of standard position with x, y, r is this. What is sine theta then? It's a ratio of x, y, and r. What is your sine? We didn't do it on this slide, but we did it on an earlier slide. What is sine as a ratio of either x, y, and or r? Y over r, fantastic. Number 2, r over y is what? Okay, your r is like your hypotenuse. Tangent doesn't have a hypotenuse in it anyway. Cosecant, exactly. Was there a question?
No.
Okay. Cosecant, because it's the reciprocal of sine. Sine was y over r. Cosecant is reciprocal of that. Number 3, tangent theta would be what? Y over x. Fantastic. Secant would be? A little louder. Secant. Yes, r over x. Perfect. Okay. Number 5, x over r would be? Cosine, exactly, and x over y would be cotangent. Fantastic. Number 7, because r is the square root of x squared plus y squared, cannot be blank. Look at the instructions for 1 through 6, and you'll see it right there. Cannot equal 0. The sine and cosine functions are blank for any real value of theta. I think they're looking for a verb there, or maybe an adjective, a participle. Because the r cannot be 0, that means the x over 0, y over 0, which is sine, or x over 0, I'm sorry. Yeah. Sine being y over r, cosine being x over r, they are defined because the r is never 0. That's what they're looking for, I think. Number 8, the acute positive angle, hint, hint, formed by the terminal side of an angle theta and the horizontal axis is called the blank angle of theta and is denoted by theta prime. Reference angle, you got it. Homework exercises here. Do either 9 or 11 or both. They have 2 parts each. Do any of the odds 13 through 17. Do either 19 or 21 or both. Do any of the odds 23 through 31. Do either 33 or 35 or both. Any of the odds 37 to 43. Any of the odds 45 to 51, any of the odds 53 to 67, any of the odds 69 to 73, any of the odds 75 to 89, any of the odds 91 to 95. And then try at least one or more of your odd number application problems 97 through 101. Okay? Then there's a true false under exploration. I would definitely do that. Think through it. You're not going to see many on your test, but still a good thing to think through. And then also think through your writing request. Now, if you see something there that could actually be your paper topic, go for it. All right. Any questions? Now that we've, yes. Before 19, any of the odds 13 to 17. And then either 19 or 21, and you got the rest of them. Okay. Now that we finished 4.4, that's what your test covers. So I gave you the test last time so you'd have an extra weekend to work on it, which I'm sure you all took advantage of to the fullest. Good for you. Surprise, surprise. But now that means technically it's due in a week, next Tuesday. The odds are you probably are going to want a little more time on it. That'll be fine, but just get it to me before we finish chapter 4. So because at the end of 4, I'm going to give you another test. I don't want you having 2 of them out at once. There's a reason for that too. If you can get it back to me before I give you the next test, or before the next test is due, you can see if there's anything you missed. You don't want to make the same mistake on test 2 that you made on test 1 because you didn't turn in test 1 until the day of test 2. So get it into me sooner rather than later. All right. Any questions? Okay. Let's go on to 4.5. Folks, you really need to get familiar with your identities. We're going to use them throughout the chapter, not just in that section or some previous section, throughout all 3 chapters, okay? You never get away from them. In fact, we're going to add to them. So get to know them. Get to use them. All right, finally it came up from current slide. So we're still dealing with trigonometry, thank goodness, that's what the course is all about. Now we're going to look at graphs. If you don't remember from 112, this book loves graphs, okay? We're looking at the graphs of sine and cosine functions, okay? So what we'll do, our objectives here is sketch the graphs of basic sine and cosine functions. Then we're going to use some other, some changes. We'll look at amplitude and period to help sketch graphs of sine and cosine functions. We'll sketch translations of the graphs of sine and cosine functions. And we'll use sine and cosine functions to model some real-life data. Good. So let's look at the basic sine and cosine curves. This section will study the techniques for sketching the graphs of sine and cosine functions. The graph of a sine function is called a sine curve. And let me tell you now, just about everything in nature and everywhere you look, you're going to see things that can be related to sine curves, okay? If any of you are going to, say, go into sort of some engineering type areas, especially electrical engineering, your alternating current follows a sine curve or a cosine curve. Your voltage follows a sine or a cosine curve. Your, just all sorts of things. Diurnal fluctuations. Temperatures follow sine and cosine curves. Tides follow sine and cosine curves. Just about everything in nature follows sine and cosine curves. I mean, they're all over the place, okay? So get used to them, okay? Get to know them. The gray portion of this graph indicates the basic sine curve, and it repeats itself indefinitely to the left and to the right, okay? It's a curve that goes like this, and like this, and like this, and like this, all the way around the room, both directions. Many times if you want to go around the room. It always repeats itself. It's what we call a periodic function. Periodic function meaning that no matter where you are on a function, sometime later you're going to be at the same place. Like if you're right here, you're going to be there again when you're here, again when you're there, again when you're over here. Everywhere within a period, you're going to hit it again. Okay? Now, the domain of this sine curve is all real numbers. It keeps going and going and going and going, never has any breaks, smooth, continuous curve. So it's special. The range, though, stays between -1 and 1 of this basic sine curve. Now, if you want to change that, you can multiply something by it. Okay? Then it'll go to whatever you multiply, plus or minus whatever you multiply by. We'll get to that later. The portion of this curve that repeats itself over and over and over again, the smallest multiple of that is called the period. And this curve starts at 0, goes up here and down here. It is 0 again here, but that's not a period. Because from here it goes down, here it was going up, so you have to keep trucking until you get over here at that 0. Now it starts repeating itself, because now it's going up from here. See, from here it's going down, so that wasn't a period. Okay? The period is when it starts repeating itself in magnitude and direction. Or back over here, it would be where it comes down here and starts repeating itself down. That would be a period. This would be a period. That would be a period. Any of those are periods. Okay? For the basic sine and cosine function, your period is 2 pi. And that sort of makes sense too. Remember, we went all the way around the unit circle and start repeating yourself. So the basic period is 2 pi. Though it stays between plus and minus 1 in the range. Because the sine function never got outside plus or minus 1. So one way to check your answer, if you have done a calculation and you come up with a sine or a cosine being 1.3, hang it up, you're wrong. Sine and cosine can never be anything outside of plus or minus 1. Now, you can multiply something in front of it and get something outside of that, but just the basic sine and cosine can. All right, with this in mind, we'll move on. The cosine function looks a whole lot like the sine function, doesn't it? If you move the y-axis here, that would be look just like the sine function. Just like it. The difference is cosine starts at 1, sine started at 0. Okay? So if you start at 1 and go down and up again, that's 1 period, and again, that's 2 pi. Okay? Range is still -1 to 1, period 2 pi, and the same period repeats itself over and over and over again. Like, once you get up here, that would be. So, good thing to keep in mind, sine starts at 0, cosine starts at 1. Okay? And trying to get where they have this. I think we've already hit this again, but let's say it again. We know the domain of sine and cosine functions set of all real numbers. We already said that. Wherever the range is between plus and minus 1 for each of them. Has a period of 2 pi. We saw that. Do you see how this information is consistent with these graphs? Hopefully, yes. Okay? So, now, we'll start next time, because I think we're out of time now, at the note at the bottom of page 299. I don't think we got far enough for any new homework exercises, so we'll get started on 4.5 next time. Okay? Now, this is not a particularly, well, it is a sort of a long section. Hopefully, we'll finish it next time, but we'll make good progress in it. Good deal. We'll see you Thursday. See if you can drag in that one person we're missing, and we'll have perfect attendance. Test? Okay. There you go. Wait, pre-calculus algebra. I know you don't want that. Here's. All right. All righty. See you Thursday.
Question.
Yes, sir.
Where is it in the book where I can find like where to spot the quadrants?
For what?
I said where in the book is there I can spot the quadrants like they show a design?
Okay. Probably back. Okay. I think it's even before here. Okay. All right. I would have thought section 1, but it wasn't there. I would have thought section 2, but I don't really see it there either. Or 3?
Yeah, see, I didn't
All right.
see any of the sections.
Here we go. Section 4, 4.4. Right there.
Okay. But what would you consider these? Just
Say again?
So what would you consider these? The axes.
Yeah, the X and Y axes. Anything between angles 0 to pi halves. This is quadrant 1. Between pi halves and pi, or 90 to 180 is quadrant 2. Quadrant 3, quadrant 4. Okay.
Yes, sir.
Okay, is that what you needed?
Yes, sir.
Okay. We probably started talking about them before that, but in the book, I'm surprised they didn't show up until right there. Okay.
Thank you.
All right, glad to.